Hey, I know what you're thinking. I really did not want to listen to my friend Mr. Porter like ever again. Sorry about that. I'm back and I'm bringing a new type of math problem that I think you're going to like. These are called permutations, and what permutations are different ways to arrange things. Permutations. You get to learn something new today. All right, let's say you've got 4 people show up. So let's roll with 4 people. How about Maya, Ben, Jay, and of course, my main man, Al. So the question is, how many different ways can you arrange these 4 people? Well, here's one, like Maya's first, then Ben, Jay, then Al. Or let's say we went with Jay first, and then Maya, and then Al, and then Ben. So there's 2. So that's the question. How many different arrangements are there for these 4 people? If you want to try and figure this out, maybe you should pause the video right now because I'm fixing to explain it and tell you the answer. Okay. All right. There are a couple ways to do this. There's the thinking about it way, and then there's kind of a slick formula way I'll show you. Let's do the thinking about it way real quick. So you've got 4 places if you want to think about it like this. Like who would be first, who would be second, who would be third, and who would be the 4th position. So you got to arrange them first, second, third, 4th. So when you go to put somebody in the first spot, right now you have 4 options. Like you could pick Maya or Ben or Jay or Al. So you have 4 options for that first spot. Now once you've chosen somebody, the 4 options now go down to just 3 people. So then you have 3 people left for your second spot. And then once you've chosen this person and this person, you only have 2 options left for 3rd place and only 1 option left for 4th place. So how a permutation works is you had 4 possibilities times 3 possibilities times 2 possibility times 1 possibility, which means you went 4 times 3 times 2 times 1, which means you had 24 different arrangements for 4 people in a row. You just solved a permutation. So 24 is the right answer. If you had that, nice job. This is the kind of thinking about it way. Let me show you a cool math problem, a math operation that you may or may not have done already. So there's a thing called factorials. So a factorial, let's say you have a number like 7, a factorial is represented with an exclamation point, like 7 factorial. What factorial means is you start with 7 and you just count down back to 1, like 7, 6, 5, 4, 3, 2, 1. So you start with whatever number is given to you, 7, go all the way back to 1, and you multiply all that together. Like that's some giant number, 5,040. So let's say you had 5 factorial. 5 factorial just means you're taking 5 times 4 times 3 times 2 times 1. So start with the number given to you, scale it back to 1, multiply all those together. That's a little smaller. I think that's only like 120. So factorial is a way to solve these permutations, all these different arrangements. All right, how about this? Let's say your job is you have 10 books and you have to arrange all the different arrangements for a bookshelf. So how many different arrangements of these 10 books are there if you arranged them on a bookshelf? Like, oh, it's a lot. It's a lot. So the way to think about this, 10 factorial, which means you go 10 times 9 times 8. So 10 times 9 times 8, 7, 6, 5, 4, 3, 2, 1, and you got to multiply all that together. So that's a lot of combinations. I think it's like 3 million. 3,628,800. If you were at school right now, there's a factorial button operation on your calculator. You could just 10 factorial and you're in business. If you don't have a slick calculator with you right now, you're like, that's a lot of pecking. Okay, let me show you some other problems you're going to have to do with factorials. Let's say you had to do this. What if you had 8 factorial and you put this over 6 factorial? 8 factorial over 6 factorial. You have to divide it. Well, 8 factorial will be 8 times 7 times 6 and all the way down to 1. 8, 7, 6, 5, 4, 3, 2, 1. 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. So if you have 8 factorial over 6 factorial, all of this cancels out with all of that. So that would just leave you with 8 times 7 is equal to 56. Now one thing that might save you a little bit of time on that, instead of writing all this out, you could have stopped at 6, like 8 times 7 times 6, but instead of writing 4, 3, 2, 1 all the way down, you could represent that with a factorial. So 8 times 7 times 6, 5, 4, 3, 2, 1. 8 times 7 times 6, 5, 4, 3, 2, 1. And the reason you could stop right there is because you have a 6 factorial on the bottom. So if you have a 6 factorial up top and you have the 6 factorial on the bottom, those cancel out and you get that same answer, 8 times 7 is equal to 56. So these are math problems that if we'd been in school, like towards May when you had the real senioritis working, these are math problems you'd have to be doing. Alright, so let's say you had something like, how about 13 factorial over 10 factorial? So again, it's probably going to be easier to write 13 times 12 times 11 times 10, but instead of writing 10, 9, 8, 6, 6, 5, 1, you would stop right here and write 10 factorial. You're like, well, how do I know to stop at 10? Like, oh, I've got a 10 right here that's going to match up 10 factorial on top, 10 factorial on bottom. They cancel out. So my answer is just going to be 13 times 12 times 11, which I think is 1716. All right, let's do one more and I think you'll have this. This one you might be able to figure out just by looking at it. What if they are almost matched up? Let's say we had 5 factorial over 4 factorial. So you look at 5, you look at 4, this will be 5 times 4, but instead of writing it all the way down, 3, 2, 1, you could just put an exclamation point or a factorial, and you have a 4 factorial on the bottom. So this factorial and that factorial cancel out, and the whole thing's just equal to 5. Okay. All right, well, let's make it interesting. Let's bring back our friends from the first example. Let's bring them back. I think we had, there was Maya, there was Ben, there was Jay, my man Al. Let's add a new friend. How about my man Zach? Okay, so 1, 2, 3, 4, 5. Let's say we got 5 people. Maya, Ben, Jay, Al, Zach. But let's say these 5 students, you have 5 students, but we only have 3 desks to sit in. So how many different combinations are there for these 5 students to fit in 3 desks? How many different ways, how many different combinations from these 5 choices can you arrange them in 3 desks? That's the question. All right, 2 ways to do this. Kind of the thinking about it way, and then I can show you the math way too. All right, think about it. So you've got your, this is desk number 1, this is desk number 2, you have desk number 3. So to fit in your first place desk right here, you have 5 options. Maya, Ben, Jay, Al, Zach. So you have 5 people to choose from. Once you get to your second desk, you've already put somebody from the 5 here. You only have 4 options left for the second one. And just like the third one, you only have 3 options left there. So for how many different combinations, the thinking about it way, 5 times 4 times 3, So you just multiply 5 times 4 times 3. There's 60 different combinations between the 5 people and the 3 desks. All right, there's a slick little math formula that will do this for you that involves factorials. Let me show you this slick little formula. So this is called n factorial over n minus k factorial. Pretty cool little formula. So your 5 students and your 3 desks, this was your n and this was your k. So 5 students to choose among the 3 desks. So how this would look, you could just do 5 factorial over 5 minus 3 factorial. And I still have a 5 up top. 5 minus 3 will be 2 factorial, which means you have 5 times 4 times 3 times 2 times 1, and 2 factorial is 2 times 1. Those cancel out. Get down to the bottom of this tiny little board. 5 times 4 times 3. So this permutation, you have 60 different, oops, you can't see that. 60 different combinations. I'll write it a little better so you can see it. So 5 times 4 times 3 is equal to 60. Okay. So cool formula to help you solve these problems. All right, let's do one more. Listen to me for one more example. Let's say, how about our man Santa Claus? And he has all these reindeer. You got Dasher, Dancer, Prancer, Vixen, Comet, Cupid, Donner, and Blitzen. That's 8. Let's even throw in Rudolph. So that's 9 reindeer. Let's say our man Santa Claus, he has 9 reindeer. And he wants to take the 9 reindeer, but he's going to take on some practice missions where he's only needing 3 reindeer at a time for the sled. So we got 9 reindeer, but we've only got 3 spots on the sleigh for the sleigh ride, for the training mission. So let's use our cool slick formula that we just learned. 9 reindeer, that's going to be your N. 3 spots on the sleigh, that's going to be your K. So how many different combinations are there of the 9 reindeer for the 3 spots on the sleigh? That's the question. So to figure that out, you've got this slick formula, 9 factorial. Boom. So you got n factorial, n minus k. So we plug in a 9 up top, a 9 minus 3 on the bottom. So this will tell us all the different combinations, like Comet, and then Dasher, and then Rudolph. All right, let's do it. So 9 factorial, 9 minus 3 is 6 factorial. And again, guys, instead of writing the 9 all the way out, what I'm thinking is we write 9 times 8 times 7 times 6, but we would stop at 6 and just put factorial because we have a 6 factorial on the bottom. So instead of writing them all the way out, we could just cancel it right there. And so my correct answer is just going to be 9 times 8 times 7. 9 times 8 times 7. And that'll give me my correct answer. Was that 504? Hopefully I can fit that in there. So there are 504 different combinations for a correct answer. Here, I'll just fit it right here. 9 times 8 times 7. So there are 504 combinations for the 9 reindeer for the 3 spots on the sleigh. So these are permutations. Thanks for hanging out with your friend Mr. Porter again. Hey, I miss you guys.